Good evening, students. Tonight, we will finish our introduction to infectious diseases. Last time, we defined the term pathogen, and we described how pathogens cause infectious diseases, or in other words, diseases that can be spread from one organism to another. So, by what methods do infectious diseases spread? We will look at three below. First, some infectious diseases can be spread through the air. For example, you see this sick person sneezing right here. And these droplets of saliva that are suspended in the air could potentially contain pathogenic microorganisms, which can then be transferred to a person nearby who breathes this air. This is one of the reasons that we cover our nose and our mouth when we cough or sneeze, and also why scientists working with infectious pathogens often wear masks while they work. Next, some infectious pathogens can be spread through direct transfer via contact with body fluids from an infected host. Some examples of body fluids that might harbor pathogens include saliva, mucus, blood, excretory fluids, as well as sexual fluids such as semen and vaginal secretions. This is why anyone who comes in contact with body fluids, such as medical professionals, research scientists, or even a good Samaritan helping out at an accident scene, should always wear gloves and protective clothing to prevent direct contact with body fluids. This is also why hand washing is important. Finally, infectious diseases can be spread through vectors, which I've put in bold here because it's a vocabulary word that I want you to know. A vector is an organism that can carry a pathogen from one host to the next. Some examples of vectors, or organisms that carry and transfer infectious diseases, include mosquitoes, fleas, ticks, and even larger organisms such as rats, bats, or dogs. Humans themselves could, in some cases, be considered vectors. Now, before I move to the next slide, first I must emphasize that not every pathogen is spread in all of these ways. Some might only be spread through blood contact and not through the air. Others only through a bite from a vector and not through contact with body fluids, and so on. Each pathogen has a specific method of transmission. Nonetheless, reducing exposure to all of these sources can slow the spread of infectious diseases. All right, now that we know how infectious diseases spread, let's discuss how we prevent and treat infectious diseases. First, the very best way to fight infectious diseases is through prevention. I can't emphasize this enough because in many cases it can be difficult, painful, or even impossible to treat an infectious disease once it has been acquired. So, what preventative measures can be taken to prevent the spread of infectious diseases? First, please get all required vaccinations. A vaccine, we're going down here to this section to quickly define vaccine. A vaccine is actually made of particles of the pathogen that have been weakened. So when you get an injection, like you see this baby in the background, what's inside the syringe is actually the pathogen that you're trying to be protected against. However, it's only parts of it and it's been heavily weakened. The reason it's important to put particles of this pathogen, to introduce them into your body ahead of time, is that your body can start to learn to recognize the pathogen. And when it does this, what it can do is it can prepare its own immune system, its own natural defenses ahead of time, so that if you ever do encounter the real pathogen in its full strength form, your body already knows how to recognize it. It already knows how to fight it. It's been pre-prepared. In addition to getting required vaccinations, we typically employ the processes of refrigeration and sterilization to help control the growth of living things. So in this case, we would be talking about our bacteria and our protists. Refrigeration, we know we put our our food in the refrigerator. That's to prevent it from growing bacteria. And sterilization, this can be anything from washing your dishes in hot water to spraying down counters with chemicals. And so these also prevent the growth of pathogens. And then finally, controlling the vectors is an important way to prevent infectious diseases. So this could be spraying for mosquitoes to prevent the introduction of West Nile virus. This could be trapping rodents that are vectors for certain diseases. This can even be when you are carrying an infection, you staying home when you're sick. By controlling the vectors, we can control the spread of the disease that the vectors propagate. Okay, so even if preventative measures are taken, we do know that many infectious diseases still find a way to infect hosts. So what can be done to treat an infectious disease once it is acquired? First, antibiotic drugs may be prescribed for some infections. It's important to know that antibiotic drugs only work on biotic factors, or in other words, living things. So we've discussed bacteria and protists are living, but we've mentioned that viruses are not. And so you can't treat a viral disease with antibiotic drugs. You can only treat diseases caused by bacteria and protists. For viral diseases, some antiviral drugs do exist, but they are less common and they often have very severe side effects. So thus, another reason vaccination and preventative steps are so important. We don't want to get to the point where we have to employ lots of antiviral drugs because those side effects can be so extreme. Lastly, please be aware that not all infectious diseases are curable. Some, like HIV or herpes, can be treated but not cured, while others, like Ebola, are still in the experimental stages of research looking for cures. I want to end our discussion of microorganisms with the important point that despite our discussion of infectious disease, most microorganisms are actually beneficial to our world. In fact, microorganisms are responsible for creating the conditions for complex life to be able to survive on Earth in the first place. And so we owe microorganisms for our existence because they produce the oxygen in our atmosphere that was required for complex life to evolve. In addition, here's our oxygen. Additionally, our digestive systems are currently places that trillions of bacteria symbiotically live. And we, in fact, actually need those bacteria because they keep our digestive systems healthy and they can even add important vitamins and nutrients that we wouldn't otherwise have in our diet through their symbiotic living and breaking down some of the food that we eat. Furthermore, microorganisms keep our environment healthy, and they do so in a couple ways. First, they are one of our main decomposers, and so, when we have dead matter, it's not all lying around. We're not waiting in it, in part because bacteria, not only do they get rid of that dead matter by decomposing it, but they also return the nutrients to the soil, keeping the environment healthy. Additionally, and we'll learn about this process later on in the year, but we have bacteria to thank for keeping our soil fertile and allowing our plants to grow because they perform an important process by which they take nitrogen out of the air and put it into the soil. And plants can't grow without that nitrogen fixed into the soil. Finally, in terms of our environment, the pollutants and waste that we add to the environment are often broken down by bacteria. And so we can see that here. This is an oil spill. One of the primary ways that things like this get cleaned up are that bacteria will digest that oil. Finally, microorganisms in general are used in the food industry to make food products that we like. So if you like yogurt and ice cream, thank a microorganism. All right, that wraps up our discussion for tonight and our general unit on microorganisms. Please take some time to think about and review these lectures, and I'll see you in class for review tomorrow. Have a good night.